Hi, this is my Physics Lab 5 and I'm doing this Slinky video. So the purpose of the experiment is to predict the motion of a falling Slinky and look at the effects of the surroundings on it. And we want to know if the bottom of the Slinky is stationary in the model like it is in real life. So I used Tracker to track the motion of the Slinky, and then I created a computational model of a falling Slinky, which iteratively calculates the position of the bottom of the Slinky. And then I'm going to compare the two. So the system is the Earth and the Slinky. And the result of the experiment is that the bottom of the Slinky does stay stationary. So some physics principles here. We use Newton's second law, which says that the change in momentum is proportional to net force. So here's the velocity update formula. And then some other forces are the gravitational force and the tension force of the Slinky, which will be equal and opposite to each other while the bottom of the Slinky is stationary. And then we also have the drag force, which resists the Slinky as it falls. So as we can see, as the top of it falls, the bottom stays stationary. And then when the top reaches the bottom, they'll fall together as one. Okay. So for the computational model, I first set all of the initial conditions, and for the proportionality constant, which is 99, I just used trial and error. So the first while loop is before the top of the Slinky reaches the bottom, so it's when the bottom is stationary. So we have an equation for gravitational force and drag force, which are equal and opposite to each other, so the net force will be 0. And we use velocity update and position update. So then the next while loop is when the top meets the bottom and they start falling together. So we have gravitational force and drag force, and there's no more tension force. So this will result in the Slinky falling. So again, we have velocity update and position update. So here were the results. This one was from the computational model, and this was from the actual experiment. So some errors that we could see back here were a little different, because in the real experiment, not all external forces were accounted for in the computational model. And also, I may have used Tracker wrong, like placed the points incorrectly. So the bottom of the Slinky remains stationary because the gravitational force and the tension force cancel out. The tension force is equal and opposite to the force of gravity, and when the bottom and the top of the Slinky meet, there is no more tension force and they fall as one.